Oxidation and reduction. Redox reactions. Oxidation and reduction take place together at the same time in the same reaction. These are called redox reactions. Oxidation is a reaction in which oxygen is added to an element or a compound. Reduction is a reaction in which oxygen is removed from an element or compound. Example: identifying the loss and gain of oxygen in an equation. Zinc oxide plus carbon right pointing arrow zinc plus carbon monoxide. ZnO plus C right pointing arrow Zn plus CO. In this reaction, the zinc oxide has been reduced since it has lost oxygen. The carbon atom has been oxidized since it has gained oxygen. Names using oxidation numbers. Transition elements can bond in different ways by forming ions with different charges. When naming, the charge on the ion is shown by using a Roman numeral after the element's name. E.g., iron can form ions with a 2+ charge, called iron 2 ions, or a 3+ charge, called iron 3 ions. The Roman numeral is the oxidation number of the element. When iron reacts with oxygen to form iron oxide, the formula depends on the oxidation state of the iron ions. The compound where iron has a 2+ charge has the formula FeO and is called iron 2 oxide. The compound where iron has a 3+ charge has the formula Fe2O3 and is called iron 3 oxide. Exam tip. You may see the term oxidation state used instead of oxidation number. Although there is a subtle difference between the two terms, this is beyond the scope of this course. They are often used interchangeably. Usually oxidation number is used to refer to the Roman numerals found within the name. Redox and electron transfer, CIGCSE chemistry. Redox and electron transfer. Extended. Oxidation and reduction. Redox reactions can also be defined in terms of electron transfer. Oxidation is a reaction in which an element, ion or compound loses electrons. The oxidation number of the element is increased. This can be shown in a half equation, e.g. when silver reacts with chlorine, silver is oxidized to silver ions. Ag right pointing arrow Ag ++ E. Reduction is a reaction in which an element, ion or compound gains electrons. The oxidation number of the element is decreased. This can be shown in a half equation, e.g. when oxygen reacts with magnesium, oxygen is reduced to oxide ions. O2 + 4E right pointing arrow 2O2. Example: identifying redox reactions. Zinc plus copper sulfate right pointing arrow zinc sulfate plus copper. Zn plus CuSO4 right pointing arrow ZnSO4 plus Cu. The ions present with state symbols in the equation are Zns plus Cu2 plus Aq plus SO42 Aq right pointing arrow Zn2 plus Aq plus SO42 Aq plus Cus. The spectator ions, those that do not change, are SO42 Aq. These can be removed in the ionic equation written as Zns plus Cu2 plus Aq right pointing arrow Zn2 plus Aq plus Cus. By analyzing the ionic equation, we can split the reaction into two half equations by adding in the electrons to show how the changes in charge have occurred. Zn's right pointing arrow Zn2 plus Aq plus 2e. Cu2 plus Aq plus 2e right pointing arrow Cus. It then becomes clear that zinc has been oxidized as it has lost electrons. Copper ions have been reduced as they have gained electrons. Exam tip. Use the mnemonic oil rig to remember oxidation and reduction in terms of the movement of electrons. Oxidation is loss, reduction is gain. Identifying redox reactions. Extended. Oxidation number. The oxidation number, also called oxidation state, is a number assigned to an atom or ion in a compound which indicates the degree of oxidation or reduction. It shows the number of electrons that an atom has lost, gained or shared in forming a compound. The oxidation number helps you to keep track of the movement of electrons in a redox process. It is written as a plus or minus sign followed by a number, not to be confused with charge, which is written by a number followed by a plus or minus sign. E.g., aluminium in a compound usually has the oxidation state +3. A few simple rules help guide you through the process of determining the oxidation number of any element. Table of rule. For assigning oxidation numbers, redox reactions can be identified by the changes in the oxidation number when a reactant goes to a product. Worked example. The equation for the reaction between chlorine and potassium iodide is shown below. Cl2 plus 2Ki right pointing arrow 2KCl plus I2. Identify which species has been A. Oxidized, B. Reduced. Answer. The species that has been oxidized is iodine. The oxidation number of I is -1. The oxidation number of iodine in I2 is 0. The oxidation number has increased, so the iodine has been oxidized, lost electrons. 2I AQ right pointing arrow I2 S plus 2E. The species that has been reduced is chloride ions. The oxidation number of chlorine is Cl2 is 0. The oxidation number of Cl is -1. The oxidation number has decreased, so the Cl has been reduced, gained electrons. Cl2G plus 2E right pointing arrow 2Cl AQ. Identifying redox reactions by color changes. The tests for redox reactions involve the observation of a color change in the solution being analyzed. Two common examples are acidified potassium manganate 7 and potassium iodide. Potassium manganate 7 KMNO4 is an oxidizing agent which is often used to test for the presence of reducing agents. When acidified potassium manganate 7 is added to a reducing agent, its color changes from purple to colorless. Diagram to show the color change when potassium manganate 7 is added to a reducing agent. Potassium iodide, He, is a reducing agent which is often used to test for the presence of oxidizing agents. When added to an acidified solution of an oxidizing agent such as aqueous chlorine or hydrogen peroxide H2O2, the solution turns a red-brown color due to the formation of iodine, I2. 2Ki AQ plus H2SO4 AQ plus H2O2 AQ right pointing arrow I2 AQ plus K2SO4 AQ plus 2H20L. The potassium iodide is oxidized as it loses electrons and hydrogen peroxide is reduced, therefore potassium iodide is acting as a reducing agent as it will itself be oxidized. 2I right pointing arrow I2 plus 2E. Diagram to show the color change when potassium iodide is added to an oxidizing agent. Oxidizing and reducing agents. Extended. Oxidizing agent. A substance that oxidizes another substance, and becomes reduced in the process. An oxidizing agent gains electrons as another substance loses electrons. Common examples include hydrogen peroxide, fluorine and chlorine. Reducing agent. A substance that reduces another substance, and becomes oxidized in the process. A reducing agent loses electrons as another substance gains electrons. Common examples include carbon and hydrogen. The process of reduction is very important in the chemical industry as a means of extracting metals from their ores. Example: CuO plus H2 right pointing arrow Cu plus H2O. In the above reaction, hydrogen is reducing the CuO and is itself oxidized as it has lost electrons, so the reducing agent is therefore hydrogen. H2 right pointing arrow 2H plus 2E. The CuO is reduced to Cu by gaining electrons and has oxidized the hydrogen, so the oxidizing agent is therefore copper oxide. Cu2 plus 2E right pointing arrow Cu. Worked example: when iron reacts with bromine to form iron 2 bromide, a redox reaction occurs. Fe plus bridge 2 right pointing arrow FeBr2. What is acting as the reducing agent in this reaction? Answer: Step 1 write half equations to work out what has gained lost electrons. Fe right pointing arrow Fe2 plus 2E. Bridge 2 plus 2E right pointing arrow 2 bridge. Fe loses electrons, bridge 2 gains electrons. Step 2 deduce what has been oxidized reduced, remember oil rig. Fe has been oxidized as it has lost electrons. Bridge 2 has been reduced as it has gained electrons. Step 3 identify the reducing agent. Fe is the reducing agent as it has been oxidized by losing electrons and caused bridge 2 to be reduced as it gained electrons.